I'm going to talk about Corey Haynes' book, Understanding the Four Rules of Simple Design. It came out last year. It's about, he's basically one of the founders of Code Retreat, of the idea of a Code Retreat. And it's about what he learned about those four rules that were formulated by Kent Beck, I think, in a lot of sessions that he facilitated in a lot of Code Retreats. This is the book. All the code examples I'm going to show are in Ruby. I don't know Ruby myself, but they are very easy to understand. Also, they all are concerning the game of life. Does everybody know what game of life is? Who does? It's not quite everybody. So the idea of game of life is it's a cellular automaton. We have this on the cover here. You have a grid, some kind of world, a playing field. And you have cells that are alive, or you don't have alive cells in that place. And there are some rules to if the cells are going to be alive in the next iteration, or if they are going to die, or if a dead cell is going to be animated. The rules are quite simple. They are going to be shown later on. I'm not going to explain this in great detail now. The whole premise of the book is that the idea of good design can often lead to a feeling that there is an Aristotelian ideal for the design of a system. This is not true, though, which we all notice because people talk about design a lot, and the discussions would be boring if we had a perfect design. So what we want to do when we learn about good design, or when we want to train design, we want to do that away from stresses of everyday work. That's why Code Retreats are great. Are all of you familiar with Code Retreats? Who knows Code Retreats? Again, not everybody. It's just going to read the slides. It's a day-long workshop focused on analyzing and practicing the decisions we make when writing code. The exercises are focused on practicing and studying the small minute-by-minute decisions we make when writing code. So it's not about the big design. Also, the simple design is not about software architecture, but rather about small decisions like what should this function be called, what should it return. I'm going to make a quick disclaimer here. In order to not be accused of plagiarism, I had the idea of giving a talk about the book when I read it, and then later I was on a conference where Mashouk Badar gave basically the same talk, and I asked him if it was okay if I could use the structure, and he invited me to actually use the slides. I basically did so. So if you've been there, you're already familiar with the talk. All right, what is simple design? It's easy. It's one that is easy to change. We write code only once. We get back to it a lot of time if we're unlucky. So we want to make code readable, and in order to easily understand what it does, and in order to be able to change it quickly. The rules then. It's 4 simple rules. The first one is that tests pass. / works as intended. The second one, no duplication. The dry in parentheses there stands for don't repeat yourself. Third rule is expresses intent. We want to know what code actually does. When we just read the function name, we don't want to have any unpleasant surprises. And the fourth rule is it should be small. We don't want any code that we never use or that is super fluent. The first rule is very easy. I don't have any code examples for that. If you can verify that your system works, then your design doesn't matter. This is not about automated tests. to make sure. It's about making sure that your system works. You can send it away to a testing company and wait 2 months for an answer. Still, it's a verification. Automated tests are nice, obviously, but we don't have to use them. The second rule is interesting now. Every piece of knowledge should have one and only one representation. It is not about code duplication, but about knowledge duplication. So what we do when we write code, obviously, we model some kind of idea or some kind of real-world interactions. And we don't want to have the abstraction into code. We don't want to represent the knowledge of the stuff we model in many different, again and again. We want one representation. We're having code examples here. The first one, this is what many people start with in Game of Life. We have a class that is the world, or the playing field, and we have 2 classes, a living cell and a dead cell. What they got is we can set a cell to be alive, we can ask if a cell is alive, and the cells have a location. So, trick question, what is the knowledge duplication in this code? Yes, please. Sorry? Yes, exactly. This is also a case of the third rule. X and Y are obvious coordinates to us. It's a cultural thing, though. But also, if we want to change that code later on to have, say, a 3-dimensional grid, we can't, or we can't easily. So what we can do is just include a new class, call it location, give it an X coordinate and a Y coordinate, and just use that class anywhere we have the X and Y coordinate. Very simple example. This is what I like a lot about the books. The examples are very, very easy. We're gonna look at that slide because I didn't explain the rules earlier. We're gonna look at it in a bit of detail. We have this class cell, and we want to see if in the next round the cell is going to be alive. The rules are, if an alive cell stays alive, if it has 2 or 3 neighbors, less than that, it dies. More than that, it dies. Living neighbors. And a dead cell comes alive if it has exactly 3 living neighbors. So what we have here is we have a duplicated number of neighbors equals 3. And a naive approach to no duplication would be, well, we are repeating ourselves there. Why not have it in one easy line? This is exactly the same as those 5 lines above. So we are reducing code duplication. But what we're doing is this does not immediately give us the rules of when a cell is alive or not. I think this is, still it's a very simple example, obviously, but this is still harder to understand directly than this. I hope you agree. If anything's unclear, please shout. Well, so why this is a naive approach to no duplication is it breaks the third rule, expresses intent. We want to come back to our code. We want to immediately see what it does without that much looking at the code as such, but at the method and class names. So paying attention to our code expresses itself is the key to making our lives easy when we come back to it. A better idea then is to take those rules and ask if the neighborhood is stable so we can stay alive, or if the neighborhood is fertile enough so we can come to life, so the cell can be animated. This still has more code than the earlier example because we are introducing extra functions, but this is much easier to read. Yes, please.
Does Ruby do implicit returns? So would that
Again? Come again?
Like the body of the if or the else, that they would be returned, right? Because there's no explicit return sentence here.
I would guess so. So the question was if Ruby does implicit returns. As I said, I don't know Ruby, but apparently. I didn't test the code. These are all examples from the book. We could have a return there to make it more easy. Thanks. Another example for the expresses intent rule is this is in test, so it's probably more your subject of clean test code. We're testing here if a new world is empty. We're creating a new world, and we're asking if it has any living cells in it. This is a bad example, a bad code example, an example of bad code in many different ways. But one way is we do have to have explicit knowledge of how the world arranges its cells, how it saves. We have to know we're having this array or something of living cells inside the world, and then we have to know that we can count the cells, the elements of that array. And the later test, again, this has a lot of things wrong with it. For example, we again have the location. We are setting a cell alive at exactly one point. We could have a rule that says that cell is always dead. And we're having the same question of is it empty or not, which is not immediately clear. Again, these are very simple examples, but the rules go for more complicated code as well. We can express our intent more clearly if we just introduce a question: is the world empty? As a Boolean function in the world. And the other test here is fixed with a false assertion if the world is empty, after we're setting it at a random location, which is my strong preference there. If any questions regarding that?
So if you have error in your code, then this test would sometimes be true and sometimes be false. Sometimes, so if you have this location random thing,
Yes.
and of course it's unlikely, but you can have code that is wrong, and this test sometimes it's green and sometimes it's red.
Very true. This refactoring here is based on the premise that these functions we're introducing are working, and they should probably also be unit tested. We don't do that here. Yes?
Random as in random or random as in arbitrary?
I'd say arbitrary.
Then it's okay. I think Francisco thinks it's actually coming from random.
All right. If you're having an infinite grid, it still could be random. But that is all things that belong to the location, into the location class. So this is one thing that's also touched upon in the book. There would be a behavior attractor for that kind of thing. So yes, arbitrary would be a much better name. Thank you. So the location class needs to know what kind of locations are valid, and that random or arbitrary function needs to return a valid location. Also, the check if the world is empty needs to be working, obviously. All right. The fourth rule, very easy. Make sure that you don't have Make sure that you don't have any extraneous pieces. I don't know how to pronounce that word. I don't have a lot of code examples for that. It's, well, superfluous code. What can we delete? We've seen one example. Does anybody know what that could be of code that we would not need in Game of Life? that many people start with but then throw away. I'll quickly jump back to it. No. Yeah. No. The wrong one. Okay. Jumping back to it. Very first code example. Sorry. I've never actually used a dead cell in Game of Life. I just save the living cells and iterate through them and see what neighbors you have, because usually you want an infinite grid at the end. So having infinite dead cells is kind of annoying when you want to iterate through all of them. Also,
TDD, you should come up with a solution that satisfies them before, right?
sorry?
If you do it with TDD, you
Yes.
should come up with a solution that satisfies rule number 4, because every code you write is required to make test ones.
But still, if you forget to refactor.
Yeah, sure.
Yeah, if you forget to refactor. Also, you can have, I mean, I did come up with code at code retreat sessions that checked if a dead cell is alive or not, and then never use that class. So that test and the class could be easily deleted. Yes.
I mean, another example of violating the fourth rule, while not violating the first three, would be going overboard with rules of clean code to the extent of things like every time one creates a class which actually has behavior, creating a separate class which holds all the fields and just having headers and setters in that second class so that the two are separated. Or having for every single class an interface behind it.
Yes.
Or something
Exactly.
along these lines. I mean, things
Yes.
that are just completely unnecessary,
Yes.
superfluous. That one thinks, well, you know, it's necessary to
Yes.
make the application.
Yes. So big design up front usually is having, as you said, interfaces that you don't ever need other implementations of. Are an obvious example of superfluous code. Also, I personally believe in this example where we have those extra functions, if you only use them once and you really want to make sure that this describes that this line of code that we deleted here describes a stable neighborhood, and you want to tell that to the readers of the code, you could also just write a comment. I know people don't like comments, neither do I, but if you only ever use it once, why not? And that's basically it. Very short presentation about a very short book. Just a few small things about the book. It tells you a lot more than those 4 rules, basically. What I liked about it a lot is it's very easy to read. You can basically read it in 2 hours if you don't linger on the code too long. You can read it for much longer if you really make sure you want to have a thorough reading of a thorough understanding of the examples he gives. Also, that's why people who are no programmers or who don't program a lot can actually understand that book, which is not true with other more, I'll say, complete books for coding. Another thing I didn't like is it only came out last year, and I really would have loved to read it like 5 years ago. Another thing, we had a bit of a discussion about that in Tenerife at Mashouk's presentation. Those 4 rules, they have an order here, and actually took Mashouk's order and not the order Corey Haynes or Ken Beck give, because they switched out 2 and 3, or Mashouk switched out 2 and 3. I personally think it's kind of a prioritization. I think knowledge duplication is the worst thing as opposed to maybe unclear function names. You want both. But also, it's what was the general consent back then in Tenerife, was that this is the order you go through when writing code. So especially with TDD, you have the whole red-green phase, which would be number one. You write a test and you make it pass. And then you refactor. And what you do when refactoring is you make sure you eliminate knowledge duplication. And then you make sure all your names are clear. And then you delete code you don't need. And then you go on back to number one. And my half hour is nearly up. Any questions? Great. Thank you very much.